this topics from basic concepts, or is the first chapter of our Smith and Vaness. No, normally we use this book Smith and Vaness for our thermodynamic studies, or KV Narayanan as well. Okay, so let us read the problem statement. A vertical piston cylinder device, okay, cylinder piston device contains a fixed mass of gas in equilibrium, and the cross-sectional area of the piston is 0.05 meter square. For 150 kPa pressure of the cylinder, the mass of piston is how much kg? We need to give the answer in round off to 2 decimal places. Assume that the atmospheric pressure is 100 kilopascal and the acceleration due to gravity is 9.81 meter per second square. So this problem was asked in the year of 2022 in engineering sciences. Now in engineering sciences, this thermodynamics is one section. One section. So that also has a lot of problems. Of course, thermodynamics there is a mechanical aspects of thermodynamics are covered in this engineering sciences. This chemical engineering thermodynamics is unique for chemical engineers. Of course, biotechnology also nowadays they are looking into, and some reaction equilibrium aspects, even metallurgy people are also going through that. Whereas the solution thermodynamics and the phase equilibrium are kind of a unique contents for our chemical engineering. Okay, so let us try to attempt this problem. Vertical piston cylinder device contains fixed mass of gas in equilibrium. So what is applicable for a gas in equilibrium? This equations of states are applicable. Okay, now what is needed is we need to find the mass of the piston. So how to find the mass of the piston? Okay, let us represent that process with a schematic, rough schematic. Okay, assume this is your cylinder which is covered by a piston. Let me this color is not so good. Okay, okay, assume this is your piston head. Okay, maybe equal diameter. So this is there is a gas confined in the piston cylinder. So what is the pressure of the gas, which is atmospheric pressure is given as 100 kilopascal. Okay, 100 kilopascal is there in the atmosphere, and the pressure inside the cylinder, the pressure of the cylinder, which is 150 kilopascal. And okay, this is the information available. And additionally, we also know about the cross-sectional area. There is the area of this is equal to 0.05 meter square. So we need to find the mass of the piston. So where is the piston? So we have this piston here. So we can make this simply write the force balance. What are the forces acting? This upward force due to the pressure inside the cylinder contents. Okay, and the downward force due to the atmospheric pressure, and also the force due to the weight of the mass of the piston. So otherwise, if you can write the force balance, so force, the internal force, how do you write force? Force and pressure are simply always pressure equal to force per unit area. So 150 multiplied by area is 0.05. There is a inside, which is to be balanced by the support, or is opposing pressure, which is opposing force, which is 100, which is pressure into area, plus there is a net downward, or there is a downward force due to the gravity because of the mass. Okay, gravitational force because of the mass. So now what we have is mg is equal to 50 into 0.05. That's what we are getting. So what is the information about G? 9.81. Now G, we need to look into the problem specification. Otherwise, if there is no mention about G, take this for 9.81. Sometime for simplification or some rounding of error, this even the gate authorities used to specify the value of G as simply as 10. So in that case, you have to use the given value, or sometimes 9.83 also they are giving, or 812, something like that. So better to take the value of G, what is given in the problem, or is look for the G value. Okay, if it is not there, you can take for 9.81. So we need to get M, which is 50 into 0.05 divided by G is 9.81. So we'll be getting the answer as I'm also going to work out. Maybe you people can work out. If you haven't noted the problem clearly, you can simply take a snapshot of this material so that you can work it out parallelly along with me. The idea is we need to solve the problem. We should be in a position to solve the problem by ourselves. Okay, what is the answer for this M? M is equal to 50 times 0.05 divided by 9.81. So 0.25 5. 0.25, sorry, 0.255 I'm getting. 2.2548 to be precise. So what is a unit here? So 0.2548 correct only. So what is the unit? Is it directly equal to kg? That we need to verify. So now let us write the unit as such. What is available for? Yeah, I'll take this, move this to this side comfortably. Okay. So here, actually mg, which is here 50 is in terms of kilopascal, and area in meter square. This is in meter per second square. So what is that of kilopascal? Kilopascal is let us write that kPa meter square by meter per second square. Kilopascal is kilo Newton per meter square into meter square by meter per second square. I suppose my audio should be good enough to be heard. Okay, sometimes since I am talking and writing, okay, I'm raising the gain value so that people can comfortably hear me. What is K? Kilo is K is 1000, and what is Newton? That is kg. Meter per second square, and already there is a meter square. So meter square by meter per second square. Meter per second square. So you check for the tallying of the units. So this meter square, this meter, this. So now, always what you are getting. So whatever you have this K per kilopascal, or is 1 kilopascal meter square by meter per second square is actually 1000 kg. So always what is the thing? Always this is simply equal to 0.2548 into 1000 kg. So always 254.8 kg, or what is the asked is round off to 2 decimal places. Okay, 254.480. Okay, of course the acceptable answer is 254 to 55, I suppose. Okay, maybe I'm not having the correct thing. So answer is 255 kg, or is 254.8 kg. Fine, to be correct. Yeah, one more has joined. Okay, welcome, Avek Singh. Okay, I expect every participant to mute themselves upon joining, and I will give time for discussion. Okay, to quickly again summarize what is asked and what is what we have done. It's about finding the mass of the piston for a given pressure of the cylinder. So the piston cylinder arrangement has a fixed mass of gas in equilibrium. The cross-sectional area of the piston is this area is 0.05 meter square for 150 kPa pressure of the cylinder. Here you may be having doubt whether this is gauge pressure or absolute pressure. So whenever there is no information available, or allowed to take it as asked to take it as simply absolute pressure. So this is 150 kPa absolute pressure, and the mass of the piston is to be found round off to 2 decimals. So wherever you work out, round off to that level. So assume that the atmospheric pressure is 100 kilopascal and acceleration due to gravity is 9.81 meter per second square. So we could represent this schematic. So the cylinder contents are at 150 kilopascal, and ambient pressure is 100 kilopascal. So, and there is a downward force due to the mass of the piston. So the total downward force is one due to the pressure, another due to the mass, and total opposing force is this pressure of the gas. So we can simply equate this force balance. Force inside equal to force out. Force upward equal to force downward. No? Upward force is 150 into 0.05, and downward force is 100 into 0.05. This is in kilopascal meter square. And mg, we are going to find this m. Simply taking this, we are getting a m of 0.2548. Of course, this is in kilopascal. No, pressure is in kilopascal, and area is in meter square, and denominator, this is 9.81 meter per second square. So we need to check what is the unit of this, whether it is, whether it is giving directly kg or 1000, whatever, what is it giving. So kPa by kilopascal into meter square by, I'm writing this entire thing. Pascal is simply Newton per meter square, and K is 1000. Okay, now simply we can cancel out the unit contents, and at last we are getting 1 kPa meter square by meter per second square is coming as 1000 kg. This is simply 1000 kg. So from which we get the answer to be 254.8 kg, otherwise 255 kg is also an acceptable answer. Yeah, otherwise what is the learning here? Simply force balance. But force is again simple, pressure into area. Otherwise pressure equal to force per unit area. So what is the area? This force is simply gravitational force, and the pressure force due to upward and downward. Okay, these are all simple only. So the essential thing is the unit conversion here. That also matters. Otherwise, we are directly getting as only 0.2548. If you try to substitute that, definitely answer is wrong. So you should check for unit conversions, proper unit, dimensionally. Check for dimensional consistency. Okay, about 15 minutes we spent for this. So shall we move on to the next one? So what could be the next one? Okay, before that, even I will also show you the already prepared solution. Say for example, this nice thing it should be. There is pressure, force downward force is due to the atmospheric pressure and gravity. Okay, and upward force is due to the inside pressure. So force balance, from which we have this. So this is available, and we are getting as 254.8. This checking for the unit. Okay, this answer, whatever we have solved right now, is also the same.